Let's wake up from the dream of all infinite possibilities of AI and let's take a reality check. What is the reality of AI and is it really as powerful as media makes it sound like? The answer is yes and no, both. You see, some of the things media says, some of that is definitely possible now. There is a big difference between when it is possible. Is it going to be possible now or in a decade, or it's going to be possible after 20 years or something? No matter what is the optimistic calculation of, let's say, scientist or even journalist, what most people agree is AI will need at least 20 years to be as smart as us. As smart as us. So those who think that they are not very smart, please know that. Now, if we talk in terms of intelligence, actually, AI system or systems. For example, let's take example of AI drones. AI drones cannot navigate as nicely as a housefly or a mosquito. There was a case study wherein a housefly was studied to understand how its navigation done, and that inspirations was used by DARPA in one of the flying fighter planes they had created. So, in terms of quality of how even a housefly flies, we are still not there yet. So, when you read articles which talk about, oh, all these things are going to be possible, what you should be asking is like, when? Is it going to be possible now? Is it going to be possible in 10 years or 100 years or 100,000 years? There is a big difference between these keywords. If that when keyword is missed, that's going to lead to an extremely wrong assumption, and we don't want to do that. So, what is a AI reality check? First AI reality check is this. You see, startups actually are using AI as an excuse. Not as an excuse, let me rephrase it. Startups are actually using AI because everyone is hyping AI a lot, and VCs now prefer a AI company to a previous non-AI company. So many startups are actually using AI when using AI is the wrong choice. They are trying to fit a solution of AI into a size of the hole which is not circular. So if we think AI as a circle solution, then they are trying to fit AI into a, let's say, triangle shaped hole. So we have to actually know that. Okay. So first is capabilities of AI. The next step is how complex it is to actually get a ML system to actually at a production scale. You see, there is a scientist who is extremely popular, Ian Goodfellow, and he actually said that for us to build a deep learning system which can work at a large scale with a brain functionality as equal as mouse. Previously, we took example of housefly. Now we are taking example of a mouse. It will take us 2050. So as long as you are smarter than a mouse, you should be set for next 30 years, according to one of the most revered scientists in deep learning field. So this is a mouse. This is not a mouse from movie Ratatouille. Okay, he is not a specialized mouse who is going to either become a cook or someone like that. It's a normal mouse. So you can imagine how hard it is to create such a large systems, and it is even harder to deploy such large systems. You see, what do we mean by deploy? Let's think of this. Currently, world population is 8 billion. If we think out of 8 billion, let's say maybe 1 in 100 has internet access. So we have 8 billion by 100. And out of that, let's say 1 in 10 is online right now. So we have, divide by 1000. So we immediately come to 8 million. So imagine 8 million people are active doing something. Let's say some Instagram filter becomes extremely popular and everyone is using that filter which uses AI. Now 8 million people at the same time asking your product to do something for it. How hard is that? You see, there are many websites I use where I can feel the sluggishness. I can figure out that there is probably a problem at the background, that servers which have been allocated to run this website, they are not complex enough, they are not large enough. So you see, actually doing a extremely big thing in AI is also hard. So what is hard? Look, doing it on a large scale, on a large data. What is hard? Deploying it for a large data. So all these things are complexities. Okay. So this is one thing which is in AI reality check. Then we have another thing which is extremely costly. It is extremely costly to get a training data. Many people do not appreciate this. If let's go for a trivia time. Okay, computer vision and NLP is called as natural language processing. So computer vision, imagine what a baby is able to understand by simply looking at a picture, and simply understand how a baby is able to understand what is being said to it. Okay, so we have CV as a computer vision, NLP as natural language processing, and in these two there is an extremely popular blog which says ImageNet moment of NLP is arriving. So let me just talk about what does that mean. It has few things, and this blog was actually a bit old blog and it has still not arrived. Okay, the blog says NLP's ImageNet moment has arrived. There are a lot of big changes in the field of NLP. Okay, there is things like GPT, there is things like transformers, there is things like encoders. All these words you will know in deep learning course. Right now this is machine learning course, but all the point I'm trying to make is different. You see, the article says that there is a data set called as ImageNet. Oops, there is a data set called as ImageNet. This data set, actually it required around 6 to 8 years to create this data set, actually collect such a large number of data, actually asking humans to label it because it can't be done in an automated manner. So because of ImageNet alone, the field of computer vision, the field of deep learning, even field of machine learning and AI became popular again. You see, there have been two AI winters. So if you watch Game of Thrones, the entire Game of Thrones concept is about winter is coming, winter is coming. Winter is a when there is, nothing grows. It's a very hard time for humanity in the world of Westeros. AI has been through two winters. Okay. And the thing which caused AI to come out of that winter was ImageNet. Not the data set, not the data ImageNet, but what this data made possible. So because there was the data, someone could actually prove that we can use this data extremely well. If the data was not present, we will never have been able to prove that AI is possible. So AlexNet proved that deep learning is possible, and it could only do that by standing on the shoulders of giants from past. The giant from the past was data. So going back to the problem, if we take a look at here, now just for ImageNet, which is computer vision, just one data set is still being used, and I think it will be same data set will be used for at least 10 more years. One data set which required maybe a decade of efforts, which was used for 2 decades at least. Similarly, we have lots of different problems which need data for that. So getting that is also a big deal. This is what we mean, that more than AI, getting data for AI is complex. So that is another reality check we should be having. It is really important. And then the final thing to actually understand is this hierarchy. So you see, right now there is most hype in deep learning. But most of the times, machine learning, which is also a part of AI, most of the times machine learning also works instead of deep learning. Now, there is one more factor here. Many times there is not even machine learning needed. So no AI needed at all. So this is the hierarchy. Don't go for the most complex way of solving the problem. Think of this as a last stage. See if there is a non-AI way of solving a problem. If there is not, then only try for machine learning. If machine learning can't give you good accuracy, then only try for deep learning. This is how you should be thinking. So in this slide, in 4 points, there were a lot of hurdles which many people crash into. These hurdles could be avoided if you were just aware of them. So hopefully this lecture gives you a reality check which can help you make intelligent decisions when you are working. So revise this, try to understand each of these points, and maybe search on Google to find more examples of each point individually. And then in next lecture, we will talk details about how are these systems of AI different from non-AI systems.